Good morning, guys. Today we will be performing this experiment for the sequential circuit. So we'll start with the multiplexer, then encoder and decoder. Okay. Today we are going to do the multiplexer 8 by 1 and 4 by 1. Okay. Let's start with an experiment. If you have any doubt, we will just do clarify at the end of the session. Sure. YouTube programming. So today we are going to do the programming for multiplexer. Okay, we will do the basic multiplexer 8 is to 1 and 4 is to 1. Okay, we start with the multiplexer 8 is to 1. Uh, the multiplexer 8 is to 1 implies number of inputs are 8 and depends upon the switches or select lines. Okay, 2 power n is number of n is number nothing but n is number of selection lines. N is selections line here, so total number of n is 3. That means 2 power 3. So 8 inputs and 3 selection line and 1 output. So you can see here select 0, select 1, select 2. Okay. So when based upon this, the data line will be selection D0, D1, D2, D3, D4, D5, D6, D7. Okay. So let us start with the programming. So I have created the project Mux1 here, add new source. So Vhdl module. So we'll write that the Mux 8 underscore 1. Next. And here previously we were giving the 1 bit input. Okay, in this case we have different type like data. For data we have 7 bit, 8 bit. For selection we have 3 bit. So how to give this data? Let us write D as an input, D as an input. Okay, so we'll click the bus here. So we'll start from 7 to 0. That means most significant bit is 7. So 7 means 7, 6, 5, 4, 3, 2, 1, and 0. So total is 8. So D stands for data bit here, and E stands for enable, which is sometime where we are using or sometime we will not use. But again, it is to enable the chip. Okay, and this is selection. Selection for this case we have 8 inputs. The selection will be how much here? So 3 bit will be the for selection. So 2 down plus 0, 2, 1, and 0. 3 bits. Okay, and Y is only one output, one bit output. Okay, next finish this. So okay. So here in this case, library IEEE use IEEE.std underscore logic entity mux 8 is to 1 for D and enable selection and Y and entity. Then start the architecture begin. Okay, after begin we have to write the main structure of the program. Okay, architecture. So let us see the architecture. Begin. Write the process. Process enable selection line and D. These three are the inputs. Okay, we are processing these three inputs. Okay, then we'll write again begin. After run process, you should start the begin. After begin, we will write the main. Okay, so we are using enable here. Okay, so if enable is equals to 1, that means I have written the single bracket or single apostrophe. Okay, if it is 1, then Y is 0. Okay, that means output is anyhow it is 0. All right, else, so first case is enable equals to 1. Okay, or Y 0, that's it. Okay, next case, if enable equals to 0, then what? If enable is equals to 1, then this is the case. If enable is equals to 0, okay, it means it is automatically, if enable is equals to 1, then it is taking automatically y or 0, okay. Otherwise, the another condition is enable equals to 0, then we will write uh, selection 0, sorry, if selection case selection, okay, selection, that means next thing, enable is equals to 1, class, this one is finished, and then selection, if selection is, okay, that means if selection line is 3 bit, okay, selection line is 3 bit, if it is 0 0 0, that means y is d naught, d naught means data bit 0, it will be selected, okay. Same case will be for the selection when it is 1 1 1. So now it will be when it is, when it is 1, so let us put that here. Okay, so when it is 0 0 0, y implies 0, 0 bit will be selected, 1 bit will be selected, data bit, okay, line, the data line 0 1 2 3 4 5 6 7. In this case I have not written, in this last, when it is 1 1 1, I have not written, that means other case, when it is other case, so other case is 1 1 1 only, so d implies 7. So now we have to end the things, okay. So first what we have to end here, and the behavior, this, and we have to do, which is the last, okay. Then we begin with the process, and we have to do, and the case, and we have to do it, okay. So first we will write and case, then we start with the if, and sorry, and if, then we start with the process, this process, and before for, okay, we, we end with this case, it end here, okay, and this case, then, sorry, it is end, okay. So it was not the keyword, so it was not showing the blue color when the keyword turned to the blue, okay. So end case, and if, then end, and so this is process, okay, then end behavior. This is my 8:1 multiplexer. Let us save it, then see the synthesize this. You will get synthesis report. Okay, and this is going to create a schematic. This is a multiplexer. Okay, so these are the, this is the selection line. You can see the selection line here. Let me zoom. So this is selection line from 0 to 2. Data is from 0 to 7. Okay, then output result is 1 bit. Okay, based upon the, based upon the enable. Okay, so save it, and we will go to the simulation process. Behavior syntax check. Okay, simulate behavior module. Okay, so in this case we have the data of 0 to 7 bit, okay, and enable, and then select 0 to 1, 2 to 0, and output 1, okay. So let us use this data force constant, okay. Previously we were getting only one value here, okay. Now we have given it as 7 bit input, okay. So let us start with this one, 0 0 0 0 0 0 1, okay. One more 0, 0 to 7, it is 4, should be one more 0 here, okay. So apply, okay. So based upon this, so let us start with this, okay? That means 0001. Now let us make enable as 0, enable as 0. Yeah. So output is 0, okay? So now based upon this selection line, now this is your input data, okay? 10001. Now we'll give the selection as force constant 000. Apply, okay? And which line will be selected here? The first line is selected. 001 means 001. The first line is selected. Let us give selection as 0 force constant. Let us make it as 001. Apply, so it is 0 here. Okay. So we have to change this to force constant is 0. Apply. So let us check again. So now the output is 1. Okay. So you can do the many iterations like this. So we'll go to the force constant, we'll go to the 0, 1, 1. Again, the output will be 0. Output will be 0. Okay. You can take multiple or you can stop here. Thank you very much for listening. And let us go to the next part, 4 by 1, multiplexer 4 by 1. Mux, mux. So let us start with the multiplexer 4 by 1. So 4 by 1 means you have 4 inputs and 2 selection lines here, okay? So add new source, it will be Vhdl module, mux, mux, underscore, look like something 4, 2, 1, okay? So next, so again we will given the inputs, so like a previous what we have given A, comma, B, comma, C, comma, D as an input. Okay, so you have 4 inputs here. That means selection 0, comma, selection 1 are your inputs, and let us take Z as an output. Okay, next, finish. Remove everything from here. Okay, so after begin of the process, you will write the statement again. So after begin process, so let me process. So what are the input and output A, B, C, D? In the previous example, what we have done here, here, just we have written process, enable, selection, and D. We are not using enable here. Okay, selection is R3 and data is, so it was very difficult task, write D0, D1, D2, D3, D4, D5, D6, D7. Okay, so just we have taken 7 down to 0. In this case, no need, just write A, B, C, D, S0, S1. Okay, enable. If we are not using case statement, just we will write a very simple if. Okay, we'll use if statement. If S equals S0 and S1 is 0, then it means that is A. 0, 1, sorry, 1, 0 is B, and 0, 1 is C. And in and this otherwise the other case will be 0 1 0 is finished, 1 0 is finished, 0 1 is finished, other case will be 1 1 only. So that means it will be Z. So and if and behavior. Let us again go to the implementation, make it as a top module. Yes, okay. View RTL schematic. Yes, save it. View RTL schematic. There is some error here. Let us see the error. The error is we have not end the process. So we'll write end process. Again, save it. And then view RTL schematic. Okay, it will be perfect now. Okay. And this is clear schematic. This is 4 by 1. This is simple. Okay. So this is after a schematic. And again, we go to the simulation process. Case, we are not going to give the simulation from the system. You can go, okay, with the keyboard, you can give the simulation process. But we are today we will see the new thing that is called as a test bench. Okay, so go to the marks for one new source. Here you can find the HDL test bench. Okay, so let me write the name TB underscore marks. Okay, sorry, test bench underscore TB stands for test bench. Okay, marks. Whatever name you want, you can give it. It is user defined. Okay, not fixed. So test bench next. So which program you want to associate this test bench? We want to associate this to the Mux 421. Okay. Next, let's finish. So now the test bench is creating. No, bench is created. Okay. Let us remove this, and we don't want this also. So here, wherever the clock is there, you will just comment it out or delete it. So we don't need clock here. Okay. So remove the constant clock from here and the clock from this. Okay, so we'll remove the clock from here also. So end process. Okay, okay. Here in the sorry. Here in the stimulus process, you have to write the program. Okay, so program I have already written here. Let me just remove and just paste it. Okay, so here we are giving A as 0, A as 1, B is 0, C is 1, and D is 0. Okay, so S0 is select line 0 and select line 0. Okay, 1 is 0 and select line 0 is 1 and select line 1 is 0 accordingly. Okay, we are running for the 10 nanosecond here, 10 nanosecond here, 10 nanosecond here. Okay, so here in this case, what you are giving is like in the previous the same thing we were giving from the system. Sorry, from the keyboard. Okay, A as 0 run, B as 0 run, C as 0 then apply, then run for this time. Okay, so now we are not giving from the keyboard now. Just we have generated some test bench and we are running according to it. Okay, so let us see the simulation process. Okay, now go to this Mux and do simulation behavior syntax check. Yes. Oh, there is some error. Um, so let us see again. Module save it. Okay. Okay, there is again some problem here. Let us start again with the process. Okay, save it. Then run it again. Again, there is some error. So let us see again 0010110. Okay, okay, then and process and so process we can see process and share. Okay, save it. Okay, perfect. Now go to the simulation process. So here you can see we have not given anything from the input from the keyboard. So just we got the output. Okay. So check for all the inputs. Here A is 1, B is 0, C is 1, and D is 0. Okay. So switch is 0 and 1. Sorry, select line is 0 and 1 here. It is 0, 0, output is 0. So select line is 0, 0, it is 0. Select line is 1, 0 means 1, 0 means what? It will be output is 0. Select line is 0, 1. 0, 1 means which line will be selected? So output is 1 means Z is 1 means A is selected. Okay. Same in this case. Let's see. Just draw it. Thank you very much for listening.
Okay, guys, just submit the report to by this Thursday, okay? And report this multiplexer and demultiplexer report I will do in the next week, okay? If thanks for watching the video. If you have any doubts, you can just listen, just write me the course message on email. I will be glad to reply you. Thank you very much. Assalamu alaikum.